Hey yo, what's up everyone? It's your boy JOHHABRAHAM. We are back with the lab course. We are looking into the lab, the general chemistry lab. Yes. Okay, okay. I gotta make sure I get this lab shit under control. Under control. This is going to be amazing. Oh no. I gotta change this thing. Just a mini. Stamini. There we go. Got him. Got him. Got him. Daily study stream. Mm-hmm. Yep. So I recently, I was just thinking. I just saw some other people's stream, where study stream. A lot of people just record themselves, just themselves as a person, not what they are doing. I'm like, what? What's the point of that? But you know what? Let's give it a shot. Let's see what is how does that thing looks like recording themselves. Maybe that gets attraction, but do I need attention? Not like that. It's just, do I need that much attention though? Well, let's see. So you go to sources and you take the video capture down here. So it's gonna be full screen. Let's say that's full screen. And you turn on, wait, I turn off this. Hey Siri, set a timer for 5 minutes. I should do this within 5 minutes. Okay, so I turn on my video capture. I should keep it up here. Yo. So, is the camera on? No, wait, it's on. Oh yeah, there we go, it's on. So I turn my background off. I know my room looks like mess. I know. What are you gonna do? What are you gonna do, huh? What are you gonna do? You ain't gonna do shit. So, wait. So screen capture should be on top, and I should make this smaller, right? That's what you were trying to say, right? If you make this smaller, I still don't get it. Even if it's smaller, I'm nowhere close. Like, bro. Wait. This ain't it. This ain't it. Think, boy. Think, boy. So we make myself small and put myself on front and the screen on the back. Oh fuck. I don't even know if it's in is it even in its original place? Yeah, it is. Okay, so that's there. What do you do with the video though? At the center? I mean, you cannot see the screen, right? When it's there. What do you do? I'm thinking. I have a better working environment right now, but I'm thinking if there's something I could do. I don't get it. To do this, but this is just fit the screen. This is just me, right? It's just me. You don't see what I'm doing. I should stop picking on my nose. What difference does it make? I could put my screen on the top left, like somewhere here, and but nothing would be readable if I put it that way. 5 minutes, okay. You know what? Let me try that. If I put it up here and I move to the left, oh no, to the right, oh, to the left. You can maybe see my screen, but I do not like this setup. This looks stupid. No. Wait, if that's the case, then let's put the camera to the left. More left. Yeah. Wait, if it's on down. Oh, I'm sorry. I'm sorry. If it's down here, no. If it's up here, I don't know. Wait, let me just first get rid of the screen. If it's here, nah. It just looks stupid. Oh, that's just my forehead. It's basically my forehead. Fuck. I keep it here. If I show this, Yeah, that's basically my face now. Is it fun? I don't know. It looks weird. Well, let me do this for 30 minutes. Let's see how this thing works. I cannot charge my phone. Yeah, let me see. So, what are we gonna do? What are we doing? I was looking into section 7. Yeah. Hey Siri, set a timer for 20 minutes. So yesterday I remember doing this part where I was confused on the magnesia stick onto putting the magnesia stick onto the half concentrated HCl. The word you're looking for is contaminated. Yes, that was the word. You are concerned that repeatedly dipping the magnesia stick into the half concentrated HCl beaker might contaminate it with salts. That is a valid concern, but the procedure already accounts for it. Why the stick is dipped in HCl first? Half concentrated HCl has two purposes: cleaning the magnesia stick, converting salts into volatile chlorides, which produce clearer flame colors. When stick is dipped in HCl and heated in the flame, any remaining ions from the previous test are burned off. The stick becomes chemically clean. You repeated this cleaning step every new salt. Are you using the HCl, same HCl beaker? Yes, you use the same beaker of half concentrated HCl for cleaning the stick, but the instruction also say replace the acid from time to time if contamination occurs. So the workflow is dip the stick in HCl beaker, put the stick in flame until no color, dip stick in dipstick dipstick in salt sample, put stick in flame, observe color, dipstick again in salt HCl. You dunk the stick. You put the stick in flame, observe color, dipstick again in HCl until heat until no color. Move to next salt. Wait. No color. Whoa, okay. If you see strange colors appear during the cleaning step, acid is likely contaminated and you prepare fresh HCl. Okay. Okay. The word I was looking for was contaminated, and if I see strange colors appearing, that means it's contaminated. So it's either I have to make more half concentrated HCl. Why contamination usually stays low. Contamination is minimal because only a tiny amount of salt touches the stick. Most ions burn off in the flame. HCl rinse dissolves remaining residue, so the acid does not accumulate large amounts of ions quickly. So I'm gonna make 20 milliliters of half concentrated sulfuric acid, hydrochloric acid, because you never know when your shit gets contaminated. So prepare analysis salt. Now my next question is related to this, where from my understanding I only have to use a little bit of the salt, like a small tip of the spatula. I know if I could just read it and find this out, but let's just give it to GPT. Let me know which of these solids I should be considering for this experiment. For section 7, you only need salts that contain the required cation listed in the instructions from the chemicals list. You pasted the following: lithium chloride, okay, sodium chloride, potassium chloride. Oh, we got all of those. Calcium chloride, strontium chloride, barium chloride, copper 2 sulfate pentahydrate. Whoa, that's the only one with copper? We got copper, acetic copper acetate. We got copper acetate and copper sulfate. Why are we not using copper acetate? Okay, why is the copper acetate hydrate not used? Good question. Very good question. I'll let you know what you gotta do. Come on, what happened, GPT? Did you just fucking... You could use, because it still contains, which is, however, the lab specifies copper 2 sulfate pentahydrate for a few practical reasons. Wait, when did it specify that? When did it specify that? For potassium salt absorbs the flames. Where's copper mentioned here? No. Cleaner flame behavior. Copper acetate contains an organic acetate group which heated in flame it can partially burn and produce extra combustion products which may cause smoke slightly after the flame appearance. CuSO4 does not contain an organic group, so the flame observation is usually cleaner and easier to interpret. Availability and stability. Very stable, commonly stocked in teaching labs, easy to handle. Okay. Oh, I need to write the reason why it's not used. Keep NaCl very far from other salts while working. Sodium contaminates everything easily and produced a very strong yellow flame. That's for section 7. Okay, I got a rough idea on section 7. Should I write it? No, before I write it, I should look into the next one. So, according to you, you told me start with section 7. I'll write that down. Because that could be useful. 1303 lab prep. Section 3 fermentation setup. Section 7 flame coloration test. And then you go to section 5.2 exactly. Well, let me see. 5.2, section 5.2, and section, come on, I know this, 10. Let me see how this works. So section 5.2. Now this is section 5.2. Let me know what is this having similarity with section 7. 1 drop of diluted silver nitrate is added to 1 drop of the following solutions. Note your observation. Fluorine is toxic. Inform yourself before practical work. Use gloves. Don't spill it. If you spill it, remove it immediately. Pour all solutions that contain fluoride immediately to a basic waste. Never mix it with any acid. Not respecting these instructions will lead to immediate exclusion from the laboratory, okay? Okay, I will not mess with fluorine. I will not mess with the F element. Don't F with F, bro or sister. Don't F with F, okay? Stop wasting time. Yep. Apologies. Section 5.2 and Section 7 share several practical aspects of the lab setup. Both experiments are performed in a multi-pit plates, so several samples can be tested in parallel. Section 5.2 precipitation reaction on a spot plate or porcelain plate. Section 7 salt placed on porcelain plates with pits. Okay, let me see the porcelain plate. How many pits do we got? I forgot. God damn it, I forgot. Wait, how do I check it? There we go. I just opened it. Bench. Fuck, it's not even loading. Yeah, there we go. So we got the porcelain plates. How many pits? We got, say, 12 pits with black and white color. So we got 6 each. 6 on black and 6 on white. How many salt are we dealing with? 7. Use of spot, very small sample qualities. Use minimal material, 1 spatula, 1 drop, 1 reaction. Multi samples tested sequentially. Both experiments require testing several ions one after another, recording observations. Examples: Section 7 has 3, 3, 6, 7. 6, 7. Don't make me do this. Section 5.2 has uh, HCO3, HPO4, 2 minus. So 1, 2, 3, 4, 5, 6, 7. Nah, 7. Okay. So we don't have enough space on the porcelain plate. Yep. Nope. We don't. I don't think they're gonna give me another additional porcelain plate, right? No. I don't think so. Not gonna lie, the light is fucking. Oh, my face is fried right now. Let me shift this thing. Let me see how that works. Oh, wait. Okay. Now we shift the screen to this side. Chat is also right there. Now if I move to the left, I move to the left. I move to the right, I move to the right. Okay, that's not supposed to be there. I don't wanna. Lo and behold. Wait. Just a minute, gang. Okay. I think it looks much better now. Ow. It's pretty sunny. Not gonna lie, it's pretty sunny. Is that gonna be useful? Kinda. Little bit. What's that? The files? Don't ask. The camera's right there. I should not have done that. It's time for my drugs. Daily set of drugs. Drugs! Yeah. This is my alternative to drugs. Okay, so we got seven of those. Seven of those. How do I say this? We got 7 samples per each section, and our porcelain plate has only 12. pits. In total, we got 14 samples involved. Is there a common sample type? No. It's all different. Nope. Both are qualitative identification tests rather than measurements. Okay, 1 drop of diluted silver nitrate solution. I think we have to do section 5, the first part too, right? Yeah. Looks like section 5, part 1. Does this part involve fluorine? Yeah, it does. So if I'm doing, I should do section 5, part 1 and section 5, part 2. Clean the magnesia stick with HCl and flame between salts. Use separate pits and avoid mixing reagents, especially with fluorine. Okay. 20 minutes? Come on, come on, come on. Focus, focus. I should set a time for 15 minutes. One drop of diluted silver nitrate solution is added to 1 drop of the following solutions. Note your observations. Acidification is the precipitated silver salts. So from what I understand, NaCl is gonna put a silver salt. KBr was gonna put a silver salt in Ki, right? 4.5 molal of nitric acid is added dropwise to the precipitates formed in part 2a. Note your observations. The solution of the precipitated silver by complexation. Prepare silver chloride, silver bromide, and silver iodide precipitates by adding 1 drop of silver nitrate solution to 1 drop of the corresponding halide solution. Wait until the precipitate is formed, then add 3 drops of the 10% ammonium carbonate solution and stir the mixture carefully with the small glass rod. Repeat that procedure twice. Prepare new precipitates. Repeat that procedure twice. But add 4 molal ammonia and 20% sodium thiosulfate solution instead. 3 drops. Okay, so first part, 10% ammonium carbonate solution, then the 4 moles ammonia, 20% sodium thiosulfate solution. Do all the experiments 2 times, 1 time with white and 1 time with black background. You can do both at the same time. Be aware that the precipitates are not very stable under UV light, so make sure you add the reagents shortly after preparing the precipitate and not after a longer time. So we do all the experiments starting from here. Okay, I could do it. It's not like it's not doable. It's just I gotta be fast. I gotta be figgity fast. So from the looks of it, it's better to study. Well, it's better to start with the part section 5. Because from what I have read, the initial silver salt solution is prepared part 1, or am I mistaken? You're mistaken about the correction connection between part 2, section 5. Are independent experiments the solution prepared in section part 1 is not used in part 2? Okay. Make a stock solution of 25 milliliters. Oh yeah, this one is iron. Make a stock solution of 25 milliliters of 0.004 mole iron 3 solution. If I did section 4, I could. And 1 milliliters of 2% potassium thiocyanate. Do we have potassium thiocyanate as solid or as f f f f f f f the experiment used to prepare. Okay. So what's this one? Potassium thiocyanate. KCA. Okay, that's 2%. We got that. We got that. Okay, that's good. That's good. That's good. Mm-hmm. This forms a red equilibrium complex. Label 8 test tubes, 1 to 8. Put 6 milliliters of the stock solution in each test tube. Reference, okay, this one is. Put 1 tip spatula iron chloride into test tube 2 and mix it properly. Test tube 1 is used as reference. Okay, put 6 milliliters of stock solution into each of the 8 test tubes. Wait. There should be 6 into 8. 48. So there should be about 48 milliliters of stock solution when you add all this. We got 25, 24, 1. So there's no other things like contraption, volume contraption type sheet. No, I don't think so. Oh shit, I forgot to do that. Not gonna lie, this thing is not that interesting as I thought. This camera part. Is it? I don't know. No, 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 no. So that's section 5. First one is make a stock solution, put it into 8 different test tubes, and check how each test tube reacts with each different stuff adding into it. Okay. Okay. That's that. So from looks of it, I could do section 5 part 2. Now section 10. Okay. I kinda from the looks of it, it could take some time as I have to repeat everything, both black and white side of the porcelain plate. Many laminated spot plates already have both backgrounds on the same plate, so you can simply place drops of... Okay, so it's not going to take some time. Okay, okay. Now, section 10. Okay, now, section 10. I should have my aqueous, organic, and insoluble separated PPTs dried when I head to the lab. Now, how is this one gonna start? I just noted down one thing where the insoluble was not dissolving or not passing through the aqueous phase. That means the insoluble precipitate has a density lower than water. If it was higher, or if it was about as water, it should pass through water. Oh, not this. I wrote it up here. So the insoluble precipitate density is less than a water. Starts after you already separated mixture. When you enter the lab, you should have the experiments, then proceed with 3 independent analysis: insoluble, Compound density measurement. 15 minutes? Okay. I got 15 more minutes. Hey Siri, set a timer for 15 more minutes. Identify this compound using cyanometer. Make sure the solid is completely dry. Weigh the empty cyanometer. Add the insoluble solid. Fill the cyanometer with isopropanol. Measure the mass again. Use the density formula to determine the solid's density. Add the insoluble solid. Should I add the whole thing, or then compare the density with literature value of the literature values to identify the compound? Water soluble compound ion identification. Here you use qualitative ion test. The manual explicitly says to use methods from 5.7 and silver salt reaction with anions. Dissolve the sample, dissolve one spatula tip in 50 milliliters of water, identify the cation. Use the flame coloration test. Possible cations. Oh, okay. Example, use salts like sodium chloride or potassium chloride as reference samples. So, okay. Now I see where identification of the organic liquid, unknown sample. Wait, organic compound water. To identify the cations and anions of the unknown sample by the method described above. You can use any method you find best to identify your compound. Just don't forget to do a blank and reference sample test in the protocol. Make sure you give a convincing argument why you identified a certain compound. Wait, so the flame coloration test is... Wait, what? Identify the anion. Use precipitation with silver nitrate. Possible anions. Examples of precipitate: silver chloride, silver bromide, silver iodide. You must always run reference test. Known salt, blank test, only water. Then compare them with your unknown. Organic salt melting point identification. This has been benzoic acid derivative you isolated earlier. Measure the melting point of your sample. Look at the literature melting points. Choose the two closest reference compounds. So melting point, it's I have to set up the not the Lebesgue condenser. Is that what it is? No. I think to get the melting... Oh, I could use the melting point measuring device. I think that's how it works. Choose the two closest reference compounds. Perform mixed melting point tests. Mix your samples. Reference A, mix your sample plus reference B. I need to know more on this. Just a minute. There's nothing to hear, but I have to. So from the looks of the identification of the insoluble is the easiest, and could you also start explaining on the identification of the water soluble? My doubts are should I do this along with section 7 or just the flame color from the section 7 be noted is so the reference test, does that mean I have to do the test with all the 7 salts? Using isopropyl as auxiliary liquid, once you calculate the density, you compare it with the literature values, water-soluble compound identification. This part is done using the methods you already learned, mainly flame test, salt, silver precipitation test, and you do not repeat the entire section 7 experiment again. Flame test for your unknown salt. You only need to test your unknown sample. However, the manual requires reference test and blank test. Just the clean magnesia stick in flame with nothing added. This shows what the flame looks like without contamination. Reference test. Use one of the known salt that corresponds to the ion you suspect. During section 7, you already observed the flames from lithium chloride. So you already know the flame colors. From section 10, you confirm your guess. Oh, okay. For the anion, you repeat the precipitation test using silver nitrate. Again, this anion test, is it for the water soluble? Because in the case of water soluble, yo, guess 1337. What's up? Crack your thumb? Nah, crack your thumb. How's it going? You just came in on the right time. I was about to end the stream in about 5 minutes, cause 1 hour. How you doing? Guess 1337. Anion identification, silver test. For your anion, you repeat the precipitation test using silver nitrate. Example: unknown plus AgNO3 precipitation forms. Sodium chloride, white silver chloride. I'm guessing I'm guessing we are talking about the uh, anion with the initial water soluble, which was changed to carbonate. Okay, it's called the common cold. Welcome to the game. Welcome to the club. Common cold. It's fucking annoying. Not gonna lie. It's just the throat infection for first 2 days. It's gonna for me. It's usually first 2 days throat infection. Then the next 2 days is gonna be just what's it called, the mucus leaking from the nose, and maybe a little bit cough, cough, whatever. Then I think then the next 2 days it's gonna start to come down. You are still in the middle of it, 3 to 4 days, yeah. So within the next 2 days it should come down. But yeah, it's this thing is annoying. It's like it's not hospital worthy. You don't if you get oh okay. Yeah, I mean the time varies differently, but yeah, the main problem is this thing is not sick enough for you to go to the hospital, but it's it's sick enough that you cannot do anything useful. It's annoying. It's a one annoying piece of little infection, but yeah, from what I understand, all you can do is uh, like not to get sick, just eat everything correctly, give your body everything it needs, so it does not catch cold next time. It's annoying, bro. Not gonna lie. Are you still having this throat infection right now, or now it changed to something else? The anion you're identifying with the silver comes from the silver. The anion you're identifying with the silver test comes from water soluble part of your unknown salt. If your water soluble compound contains a carbonate, you have to account for it. Carbonates can react differently than halides with silver. If your water soluble compounds contains carbonate, you have to account for it because carbonate can react differently with halides. Typical silver precipitation works mainly for halides, sometimes for OH, but carbonates from form silver carbonate, which is sparingly soluble and behaves differently. So yes, the cation is identified via flame test. Anion is identified via silver precipitation test. I mean, I know the anion is carbonate, right? Wait, wait. I know the anion is carbonate because that's that's what we used to separate the dissolved metal salt into a precipitate by adding K2CO3. Exactly. If you use K2CO3 to precipitate the metal from water soluble part, then the anion left in the solution is carbonate. That means for your unknown, the cation is whatever you got precipitated by carbonate. You can confirm it with flame test or density. Guess 1337 was at least there's one good thing about getting sick now. When you get sick now, you're not gonna get sick for a while. That would be a good side of this. But that's not for sure though, because at at the starting of this year, I got the common cold. I was like, fuck, this shit's annoying. But I was thinking, okay, at the start of the year, I got a common cold. That means for a while, there's not gonna be anything like this. But guess what? After 2 months, boom, done. You done, son. Oh yeah. Skipping school, being sick. The good old days. Good old days. Not gonna lie, being sick is annoying, and sometimes it just feels feels good. Just being in the room, just being in your bed, just with the phone, with the tablet, you can just keep on scrolling. But on a productive scale, on a productive side, you are doing shit. You're still conscious, but you are not strong enough to do anything. That's the annoying side of being sick. If you use that, what you saying, dog? That's what I used. In section 1, it's already said. Uh, prepare for saturated. Look at this. It's already on section 1. 1! The anion. So does that mean I could skip it? Or I should do this anyway? I feel like I should do this anyway. Wait, I don't know. I need to ask my professor on this part. You can use any method you find best to identify your compound. Just don't forget to do a blank and reference sample for the test. In the protocol, make sure you give a convincing argumentation why you identified a certain compound. Mm-hmm. Okay, let's discuss this again. So I should first solve a small bit of the sample. I just banned my test account on Discord. How do I see that? Member banned, okay. Interesting. Oh no, this member was a chilling artist, coder, writer, religion, minor, teen. It was everything, bro. Okay. Okay, at least the banning part works. That's good to know. But hey, you should take rest, okay? You should get the good rest when you're sick. I should first dissolve a small bit of sample. sample in what? In water, in 50 milliliter water. Then I dip the magnesia stick in the half concentrated HCl, then onto this solution and burn to see the color and use the original salt that produced the color from section 7 again to confirm that was it. That's exactly the right approach for identifying cation. I don't know if that's the right approach because ChatGPT can't just say some random shit. To solve your unknown water sample, take a small spatula tip and dissolve in 50 milliliters of water. This is your test solution. Prepare the magnesia stick. Dip the magnesia stick into half concentrated section 7. This cleans it and helps it pick up the ions. Test the unknown solution. Dip the HCl coated stick into your dissolved sample, then hold it in the flame of the telco burner. Observe the flame color. Compare with known references. Use the original salts from section 7. Test them in the same way to see which cation gives the matching flame color. This confirms your unknown cation. Run a blank. Dip the magnesium stick in HCl and then water only, no sample, to ensure there's no flame color from acid or water itself. The first repetition you do on your own if you're not correct. Okay. If you want to check your sample for specific ion, you can always you have to perform a reference and a blank test. The reference and the blank test work exactly as the ion test, but instead of your sample, you use your reference salt or nothing, okay. Thus, the reference test will show a positive test and the blank a negative one. Then you just need to compare the test result of your sample with them to find out the ion present in your sample or not. A white precipitate alone is not very conclusive, so try to substantiate with additional experiments. Okay. Now the different benzoic Guess 1337. Do you think this the camera thing is good? I was just trying this out. I don't know if this is good. I feel like my screen is not visible. And is there any point in seeing me doing shit? I don't think so. So it's been more than 1 hour. You know what? I'm gonna end the stream and I'll start with this one. I have to start with LinkedIn. Yes. Let's see LinkedIn. Let's see what LinkedIn do. So I'm gonna end the stream and we're gonna start with LinkedIn. I'm gonna start. I believe using LinkedIn on YouTube I don't think I'm gonna leak any information. I need to check on that, but yeah. Peace. Let me just